In this example, the question asks us to find the distance between the plane as given by this equation at a point of this. So the first thing you do when solving this question is to substitute the points into the equation to see if the point is on the equation. So if I substitute the values in, I get 4 times 10 plus 2 times 3 plus -8 minus 16, which equals 0. And if left side equals the right side, this means that the point lies on the plane. So if I keep going, I'll get something like this. And when I add them up, I get 46 minus 16 minus 8, which does not equal 0. So we say that left side does not equal right side, and therefore the point does not lie on the plane. Now, a normal vector to the plane can be stated as n vector, which equals 4, 2, and 1. And how we get these points is we look at our x coefficient, our y coefficient, and z coefficient. Now, from this, what we do is we choose any point, let's just call it Q, on the plane, and select arbitrary values for this. So, this is just a point. So we will choose x equals 4 and y equals 0. So the next thing we will do is figure out what the z value is, and by doing that we will be subbing it into the plane equation that's stated here. So if we do that, we get 4 comma 4 plus 2 0 plus z 16 equals 0. We have 16, this gives you 0, plus z minus 16, those two cancel out, so z equals 0. So we get our point Q4, 0, 0. And we know what P is, we know what Q is. We could do PQ, which is essentially Q minus P. Sorry, these are points. And if I do that, Q is 4, 0, 0, and then the point is 10, 3, -8. Expanding this, you'll get -6, -3, as well as 8, which is PQ vector. And now we know PQ vector, I'm going to be introducing a new equation. So D, which represents the distance between a plane to a line, is represented as absolute value of n dot, in this case we have PQ, so we'll use PQ, over the absolute value of n. So when you sub in all these values, you'll get 4, 2, 1, dot product of -6, -3, and 8, all over square root of 24, which again is the absolute value of n vector, would give you -22 over root 21, which equals approximately 4.8. And therefore, we know this value represents the minimum distance between point P and the plane by this equation, which is the unit we'll use is 4.8 units, because in this question they didn't give us any sort of units such as meters or centimeters.